السلام عليكم. السلام عليكم. الصوت واضح؟
Yes.
Okay. Just 1 second. I'm gonna accept all in the waiting room. Okay, Bismillah. You see my screen?
Yeah.
Okay, perfect. Yeah, I have another 3 in the waiting room. Bisan, I can accept you. Bisan, you good? I tried to accept you many times. Bisan?
Good.
Okay. Okay, inshallah, we're gonna start first class in physics. So I'm gonna use this reference. I don't know if you're familiar with this. This one. You are using this one in your school? Hello?
No.
Okay, so I'm gonna use this. AQA Physics 191 higher. We're gonna start with the energy first class. So I'm gonna explain the ideas first, and then we're gonna explain the mathematical formulas, and at the end we're gonna do some exercises. Okay, you ready?
Yes.
Okay.
Okay.
So first we're gonna start with the energy stores and transfers. Can you mute yourself, please? Mute yourself, please. Okay. Okay. First, we're gonna define a system. System in physics is an object or group of objects. So if you have a system of particles, system of electrons, system of molecules, this is called system. If something change in the system, the energy transfer between it stores or the surrounding of the system. So the energy change between the system and the surrounding due to energy transferring from one point to another because of the change in temperature, the change in pressure. So the system group of objects, and if something happen inside the system, the energy transfer between the stores or to the surroundings. Closed system means the system without no change in energy. No energy can escape to or enter from the surrounding. So the total energy in a closed system never changes. Okay, what are the types of energy stores? We have many types of energy stores. Kinetic, the first one. Kinetic energy means energy of an object because of moving. So if you have something fixed or stationary without motion, the kinetic energy equal to 0. So kinetic energy related to the motion of the object. So once the object move, so the kinetic energy start to increase according to the increase of velocity. The second type of energy stores is gravitational potential. Potential related to height. Energy an object has because of its height above the ground. So if you have any object on the ground, so the total gravitational energy is 0. But if you have energy, if you have object with a certain height, the total gravitational energy will be increased from 0 to a certain value. Let me accept the others. I accepted all, but I have 2 in the waiting room. Okay, so guys, if we have position A and position B, and if I need to ask you what is the kinetic energy here and what is the potential energy, who can answer, guys?
The potential energy is B when the B above the ground, and kinetic energy is when A moves to B.
Okay, don't give me number, give me estimated value, maximum, minimum. Potential energy will be, you have height here, right?
Yeah.
So what is the potential energy is going to be? Maximum. And the object is at rest, no motion, like roller coaster. So what is the kinetic energy here? No motion.
It's equal to 0.
Exactly, equal to 0. What about point A?
The opposite.
Yeah, exactly. Potential energy, we don't have height, so potential energy equal to 0, and kinetic energy is maximum. So we're gonna take the first law, the difference between potential and kinetic energy. Potential energy is potential energy is mgh, and kinetic energies have mv square. So as you see, the mass of the object is constant. Do you know what is G?
Yeah, I think it's like the gravitational force on Earth, which is like
Yeah.
9.8 or
Yeah,
something.
exactly. Who answering? Amira?
Yeah.
MashaAllah, Amira. So G is the gravitational potential acceleration, 9.8 meter per second square, and also constant. So what is the variable here? The one change, H. So if you are in this position or that position or that position, mass is the same, G is the same, we are in the same planet, but the only factor change is H. So H represent the potential energy. As the H increases, potential energy increases. As H decreases, potential energy decreases. So this is the height. That's why in the definition we said this is the potential acquired by an object because of its height. For the kinetic energy, the equation kinetic energy equal half mass is constant. And what is V square, you know?
Yeah, it's this like the velocity.
Velocity. So that's why the kinetic energy related to the velocity. Kinetic energy related to the velocity, potential energy related to height. So do you have any question here? Let me read the chat. MashaAllah. I have many answers in the chat. Muhammad Al-Husseini, you said no voice? You hearing my voice? Hello? Guys, you have to participate. Okay, Adam, I got your answer. Yahya, I got your answer. MashaAllah. Okay. But you can, sometimes I'm going to ask you to participate, so you can unmute yourself and participate with me. We're going to go back to the definition of energy stores. So kinetic energy, I think now you fully understood that the kinetic energy related to the velocity of the object or motion of the object. So energy an object has because of its because it is moving. Gravitational potential energy an object has because of its height above the ground. Elastic potential, let me explain this for you first, and we're gonna go back to the definition. If you have a spring like this, and you put some weight here, whatever, 1 kilogram, for example. So the spring will be, what happened when you put a mass on the spring?
It's gonna stretch down.
Yes, so the spring will be stretched down by extension delta X. Sometimes it is a symbol is E used for the extension, or delta X, the same. So the elastic potential energy equal half kx square, or if you need to use E, half ke square. So k is constant. K is constant, and this is called the spring constant. Half is constant. X square is the sorry, is the extension of the object after applying a certain amount of mass. So if we go back to the definition of elastic potential energy, an elastic object has when it's stretched or compressed. So I don't need from you to memorize the definition without understanding the meaning. So kinetic energy, I think now you fully understood that the kinetic energy, I saw the ball rolling from the certain height to down, and at this position, it has a maximum velocity. So the kinetic energy related to the velocity. And here the potential energy is 0. And at this position, potential energy is maximum. So potential energy related to height. Elastic potential energy related to compressed or extension of an object, but not an object. It should be elastic object to have extension or compressed case. Okay, so we're gonna go back to definitions. Thermal or internal energy. Thermal or internal energy. Energy an object. Energy an object has because of its temperature. Thermal related to temperature. So if you have two objects, one with a lower temperature, another one with a higher temperature, the thermal energy will be different between them. So thermal energy doesn't relate it to motion, doesn't relate it to height or compressed or stretched case. It is related only to the temperature of an object. So the total kinetic energy and the total potential energy of the particle in the object give you, if you add them, you can find some change in temperature. So the temperature related to the thermal or internal energy. Another energy stores called chemical energy that can be transferred by chemicals reaction involved everything for food, chemicals in batteries, and so on. So if you have any chemical reaction and after finishing the reaction, there are some energy released from this reaction, this is called chemical energy. Nuclear energy, energy stored in the nucleus of an atom. This is easy. So the nucleus of an atom, which contain proton and what in the nucleus? Proton and what?
Neutrons.
Neutrons, exactly. So the energy there is called nuclear energy. Magnetic energy, the energy a magnetic object has when it is near a magnet or magnetic field. If you have two magnets and you move them away from each other, you're going to find some attraction or repulsion. This is called the magnetic force. Electrostatic force, energy stored object, energy a charged object has when near another charged object. So if you have a charged particle Q and another charged particle, so there are some energy there. This energy called electrostatic energy. Okay, we are done with the energy stores. Now we're gonna know what is the energy transfers. Energy can be transferred to and from different stores by different forms. We're gonna take 4 of them. Number 1, heating. Energy is transferred from one object to another object with lower temperature. So the object with higher temperature change energy to the object with lower temperature by heating. So this is the first one. Another one is waves, like light and sound waves can transfer energy by radiation. Another form of energy transfers, electricity, when electric current flows from one part to another on the wire, if you have wire, like when you charge your phone, or when the energy transfer or the electric current flow, it can transfer energy from one position to another. Mechanical work or forces, when you push any disk, the energy transfers by motion or mechanical work. Energy is transferred when a force moves or it changes the shape of an object. So if you move the disk from one position to another, you have a mechanical energy or mechanical work. Okay, so here is a sum of the energy examples of energy transfers. So we did some of them there, so we can go back. When this plug hit the ground, when you stretch a rubber band, energy from your chemical store is mechanically transferred to the rubber band elastic potential store. You can read this later. Okay, so now we're gonna read the energy equations. I explained this. Potential energy equal mass, time, gravitational field, time, height. I did this in one note over here. Okay. And an object kinetic energy depends on its mass, energy equal half mv square. Power. I'm going to explain power to you. I did this too, elastic potential energy. So we missed the power. Let me explain the power to finish the mathematical formula needed for this class. Okay, power by definition equal energy per unit time. So power equal E, energy divided by time. Or we have another definition for power. Power equal work per unit time. So power equal W over T. We're gonna use the first one or the second one according to the givens of the mathematical or the physics problems. Now I need to give you the units for each one. We took gravitational energy. We took potential energy. We took kinetic energy. We took elastic potential energy. Is mgh, is half mv square, and this one is half kx square or e square. The unit here is joule. Unit here is joule 2, and unit here is joule. And joule equal, what's the unit of mass?
Energy.
Yeah, we're gonna use the kilogram. Do you know what is the unit of elastic gravitational
Newton?
potential energy?
Newton?
No. This is acceleration, sorry, gravitational potential acceleration. This is
Oh,
like,
meters per second square.
yes. This equal meter per second square. Do you know what is the unit of height?
Yeah,
Meter, centimeters.
So you have kilogram, you have meter, and meter is meter square divided by second square. So joule equal kilogram meter square per second square for all. Kilogram meter square per second square. So for the power, let me give you the work first. Work equal force time distance. Force is Newton, distance is meter. So Newton is kilogram meter per second square multiplied by meter. It's going to be the same kilogram meter square per second square, which is joule. So work also is measured by joule. Work is measured by joule. Power equal either energy per unit time or work per unit time, right? So it's going to be kilogram meter square per second square divided by second square. So it's going to be kilogram meter square per second cube, which is, you know this, what is the name here? Power. You don't know what is the unit of power?
Work done. Newton, sorry.
No, not Newton.
Work done.
Unit of power is what?
Work.
Okay.
Watt.
Yeah, so don't confuse between.
Is it a double T or a double A?
No, double A. So don't confuse between the unit of force, the unit of work or energy, and the unit of power. Force, mass times acceleration, right? Mass times acceleration. Energy or work, we have many formulas. It is going to be force times distance, and here is going to be W divided by T. Mass times acceleration is kilogram meter per second square. This one is kilogram meter square per second square. This one is kilogram, the power meter square per second cube. The first one is called Newton. Second one is joule. And last one is what?
what?
Watt.
I think.
Yeah, I bought double. No, this is not right. I bought supposed double. Okay. Do you have any questions here?
No.
Okay, so useful and dissipated energy. Energy cannot be created or destroyed. It can only be transferred, usefully stored or dissipated. Dissipated energy is often described as being wasted energy. So if you have total amount of energy here from the certain lamp, so some of the useful energy transferred by light in this case, or by the waves, and dissipated energy transferred to the thermal store of the surrounding. This is wasted energy. So as you see from here, energy is never entirely transferred usefully. Some energy is always dissipated, meaning it is transferred to less useful stores, as you see. So in mechanical, to avoid the dissipated energy in machine work done against the force of friction usually make the energy to be wasted because of the energy transfer to the thermal energy. So to avoid this, we have lubrications and streamlining. Lubrication is a way of reducing unwanted energy transfer due to friction. Streamlining is the way of reducing energy wasted due to the air resistance or dragging water. So last point here, we're going to define efficiency. Efficiency, the amount of energy you gained divided by the total energy or total input energy. So efficiency, useful output energy transfer in joule divided by total input energy transfer, or useful power divided by total input power. Okay, so I finished the first class now. So we need to review the definition together. So I'm gonna pick one of the definition and choose one of you to tell me what you remember from these definitions. So chemical energy store. Who's gonna define this? Chemical energy store. Malak? Chemical energy store. You have to participate. Malak. Okay. Adham.
Energy transferred by like foods and fuels and chemical substances in general.
MashaAllah عليك. Thank you. Thank you, Adham. Closed system. Amina?
I think it's where a system where the energy won't where the energy transferred won't be lost, and so it won't go to waste.
Yes. So we don't have any energy transfer, right?
Yeah.
Yes. Dissipated energy. Radwa? Dissipated energy. Radwa? Okay, guys, you have to participate. You have to participate. So I have Adham and Amina who's participating. Who's talking?
I'm sorry, I have a question. Can I count the amount of dissipated energy by subtracting the total power, the total input energy minus
The useful.
Yes.
Yes, exactly. Amina?
Dissipated energy is energy that goes to waste.
Yes, exactly. Efficiency. So Amina and Adham, guys, if you need to continue with me, you have to participate. Hussam, Tariq, Muhammad. I need new faces to answer these questions. Yahya.
Efficiency is useful output energy transfer over total input energy transfer.
Okay, mashallah عليك. Elastic potential. I have Bisan. Bisan, I pronounce your name right?
Yes, elastic energy that by any elastic object that like rubber band.
Yeah. And related to what?
Related to
I'm gonna give you choices. Related to velocity, motion, or height, or compression and extension.
Compression and extension.
Okay, thank you. MashaAllah. Gravitational potential. Radwa, Muhammad Hashim, Wael, Malak. Okay. So I have Amina, Bisan, and Adham, who is participating so far. So Amina, can you answer?
Yeah, so the gravitational potential depends on like which well, it's different from on which solar you're gonna be standing on, or depending where the body is. And so I
Yes.
think that's an example of the Earth earlier, which said that it was equal to about around 9.81. So it's like how much it's gonna attract your weight down towards the center of the earth, or like towards the center of the mass.
Okay, thank you so much. Last one, work done. Work done. Work done. Adham.
The amount of force made.
Work done is equal force times the displacement of the object.
Yes.
Thank you. Okay, so we're gonna do a quick revision for what we covered. Question 1, name the 8 energy stores: kinetic potential, gravitational potential, elastic potential, thermal, chemical, nuclear, magnetic, electrostatic. Name the 4 ways. Can you mute yourself, please? Let me check who's unmuted. Okay. Name the 4 ways in which energy can be transferred: heating, waves, electric current, and mechanically by forces. What is the system? An object or group of objects. Closed system, we defined the closed system. Work done, energy transferred when the force moved an object. A unit of energy, joule. What is 1 joule of work? That's why I give you the kilogram meter per second. Work done when in a force of 1 Newton cause an object to move 1 meter in the direction of force. Energy transfers when the moving car is slowing down. This is the mechanical energy. Describe the energy transfer when the electric kettle is used to heat water. This is the current. The electric current in the kettle transfers the energy to the heating element. Thermal store energy is then transferred by heating from the heating element thermal store to the thermal store of the water. So you have 2 different types of energy transfer here: electric current and the thermal energy. Describe the energy transfer when a ball is fired using elastic band. So this is mechanically transferred. Describe an energy transfer when a battery powered a toy car is used. So electrically from the chemical store of the battery to the kinetic store of the energy of the small car. Describe the energy transfers when a falling apple hit the ground. Energy is transferred falling apple, so from kinetic store to thermal store, because the hitting the ground, some of the dissipated energy will be lost by the thermal kind of as a thermal energy of the surrounding by sound wave. Name the unit that represents the joule transferred per second. Joule per second, it is the work per unit time. This is the watt, 1 watt, okay? So this is mathematical formula. Okay, I'm gonna answer this with you, and then you're gonna answer the other questions. Microwave is marked as having a power of 900 watt. So we have the power. How long does it take to transfer 13,500 energy of joule of energy? So let me take this to the OneNote file over here. Okay. So I'm going to give you my way to answer the physics problem. First of all, write the given, and here write the unknown to make everything easy. So the given here is the power, which is equal 900 watt. How long? So we need time. Energy transfer. So this is the energy, which is 13,500 joule. Okay, the formula I know, power equal watt per unit time, right? Sorry, equal energy per unit time. Energy per unit time. So energy equal PT. So you can do like this if you want. Here is the energy, and here is the power, and here is the time. So to find time equal energy divided by power. So time equal energy divided by power. So energy is 13,500, 9,000. So you're gonna answer this by calculator, and the unit of time is seconds. Okay, very easy. Just rearrange the equation to find the unknown. So if we go back to the book here, it's over here, 13,500 over 900 is going to be 15 seconds. So can you answer this question? First one, an LED lamp transfers 360 joule of energy in 30 seconds. Calculate its power. So please answer and send me the answer in the chat. Okay, Yahya, you can go. Can you answer this and send me the answer in the chat, please? Give me the final answer with the unit, Amin and Adham. Give me the final answer with the unit. Wael, I got your answer. Bisan, Amina, Ro'a, MashaAllah. MashaAllah. Radwa. Okay. Radwa, welcome back. Wael, MashaAllah. Perfect, guys. Can you do the second one? An electric cooker transfers 3 million joule. Be careful. Be careful. 3 million joule of energy in 5 minutes. Calculate its power. You cannot divide the million joule by minute. You have to change the million joule to joule, and you have to change the minute to second, and then answer the questions. Amina, you right, mashallah. Wael, you right. Mashallah. Ro'a, you right. Radwa, you right. Bisan, you right. Mashallah. Perfect. Can you do number 3, please? An electric kettle has a power of 3,000 watt. How much energy does it transfer in 45 seconds? MashaAllah, MashaAllah. Amina, MashaAllah. First answer.
I just have a question.
Yes.
Okay, so the time is in seconds. The power is in because like I just want to know which one is in what and which one is in joule.
Power in what? Energy in joule.
Okay, thank you.
So the number you gave me, you have to write joule in beside it.
Yeah. Okay, thank you.
Ra'a, you right. Bisan, you right. Radwa, you right. MashaAllah. Amina, you right. MashaAllah alaikum. Okay, last. I think this is the last question. Yeah, number 4. Rearranging the equation linking the efficiency, useful power input, output, and total power input to calculate the total power output of the system. So I need to give me a formula or equation, the total power output equal blah blah blah. If you need the general equation or general formula, I'm gonna show it to you for 1 minute over here. This is the one we need to rearrange to find the total power output. Okay, guys. No, we need efficiency, Amina. Efficiency, not the equation of the normal equation of power. Yeah, so Bisan, you give me efficiency equal useful power output divided by total power input. We need the total power output in one equation, in one side, sorry, and all terms in the other side.
Do you mind just like scrolling up to
To the equation again?
the please?
Okay.
All right, thank you.
Okay, I'm waiting your answer. Just give me the total power output equal efficiency divide or multiply by the total power. What do you think? You need help in this? Okay, I'm gonna help you.
It's just like the output is like I'm sorry. Can you mind going back up to the equation?
Okay, I'm gonna show you now. And this is the equation.
And we're trying to find the useful output.
Yes.
So we're gonna multiply.
This beside each other. So the question asking, rearrange the equation linking efficiency over here, useful power output over here, and total power over here, to calculate the total power output of the system. So if you have equation like X equal Y over Z, X is the efficiency here.
Oh, so we're trying to find Z.
Y is the useful power output. Z is the total power input. So
Oh,
we
so
are,
we divide
looking
Y by
for Y, right?
yeah.
So Y equal just multiple by Z, multiple by Z. So cancel out. So Y equals ZX, right? So the same here, total power
Yeah.
output equal efficiency multiple by total power input. That's it. So move to the mathematical formula and you're gonna understand it. Okay. So let me go back here. So we finish this, we finish that, we answer all the question. This is the brackets. Let us take one question and then we good for today. This is all questions. You can brackets at home. This is all for the chapter 1 or lesson 1. And then next week, inshallah, we're gonna take the energy transfer by heating lesson 2. So let me give you the last question before finishing the class. Last question, let us do one related to elastic potential energy. Yeah, let us do 1.2. The spring has a spring constant, 20 Newton per meter. This is K. When the student pulls the spring, it extends by 0.2 meter. This is E. Calculate the energy stored in the spring. This is very easy. Can you do this, please, and give me the final answer? If you need the formula, equal half K X square or E square. Let me check the answers. Amina, you change your mind. Which one is right, the first one or the second one?
I think it's the second one.
Okay. Adham, you asking me or you answering? Guys, when you give me the answer, please put the unit. Put the unit. Unit of energy, joule. Try when you answer any question to put the unit. Amina, you right, mashallah. Adham, you right. Bisan, you right, mashallah. Anyone else need to try? Okay. Ro'a, you right, mashallah. Okay, guys. This one is elastic potential energy equal half K E square or X square, whatever. Oh, this is here, not here. Half K E square. It's going to be half multiplied by 20 multiplied by 0.2 square. Half multiplied by 20 is 10. 0.2 square is 0.04. 10 multiplied by 0.04 is 0.4 joule. Without calculator, without using any external calculations, it's 0.4 joule. Okay. Okay, guys, I done for today. Do you have any questions? What is your feedback? فهمتوا حاجة؟
Yes.
Yeah.
الحمد لله. بيسان، أدهم، رؤى.
وانا تهت شويه بس بعد كده فهمت الحمد لله.
طيب الحمد لله. إن شاء الله الحصة الجاية مش هتوه.
أنا الحمد لله فهمت.
ما شاء الله، ما شاء الله. إن شاء
أنا
الله.
طالعة قبل الامتحان بساعة عشان ألحق الزوم.
ما شاء
يعني 3 ساعات وخدته ساعتين وجيت.
الله.
بس الحمد
كويس.
لله.
الحمد لله. إن شاء الله next week we're gonna take the second class energy transfer by heating، وإن شاء الله نبقى ممتازين. لو مش معاكم السورس ده أنا ممكن أبعته على الإيميل يعني إن شاء الله. أوكي. مين هيحضر SAT معايا بعد نص ساعة؟
Is it the math class?
ده ماث يعني.
ان شاء الله يعني.
إن شاء الله. يلا see you إن شاء الله. السلام عليكم.
Thank you.
باي باي.